Now, in this video, we will going to take up one more problem on projections of lines. How to analyze this problem in 3 dimension and also how to solve it by using the manual sketch. The problem reads as, draw the projections of a line capital PQ and find its apparent length, comma, true length and true inclination with HP. When the line capital PQ has its end capital P 25 mm above HP and 20 mm in front of VP. The distance between the end projectors of the line when measured parallel to the line of intersection of the HP and VP is 60 mm. The end capital Q is 50 mm above HP and the line is inclined at 30 degrees to the VP. So what he has given, the one end of the point is given, which is 25 mm above HP and 20 mm in front of VP. The distance between the end projectors when measured parallel, the distance between the end projectors both in the front view and as well as in the top view is given, which is 60 mm. The end Q is 50 mm above HP and the line is inclined at 30 degrees to the VP. He has given end Q, which is above HP. So once you get the above HP and he has given the distance between the end projectors, so you will go to get the front view. But in the top view he has given the line which is inclined at 30 degrees to VP. That means he has given the true inclination with respect to VP. So how can be done? In the front view line you make it parallel, so you are going to get the true length in the top view. So this is how you will be able to do that. Now let us see how this will be worked out. So now the first thing is you take this problem here in 3 dimensions. How to analyze this? So the end P is 25 mm above HP. You can see the distance, that is the end P is 25 mm above HP. When you look from the front view, that image will going to fall in the vertical plane. So that means you have 25 mm above HP here and you mark this point as P dash and capital P. Then the NP is also 20 mm in front of VP. So which is the in front of VP? The distance between these two is the in front of VP. Where you can see that in front of VP distance, I can see in the horizontal plane. So that is this line, what we are talking about. So when you look from the top view, I can see the distance in front of VP here. And you mark this point as small p and capital P here. Then he has given the distance between the end projectors. So when you draw this, you have a projector P in the front view and also in the top view. So from here you measure 60 mm and draw a vertical projector. And also from here you measure 60 mm and draw a vertical projector here. And he has also given the distance above HP. So which is the distance above HP? When you look from the front view, you can see the distance above HP. The distance can be seen in the vertical plane. So from this XY line, you draw a horizontal projector which is at a distance of 50 mm from the XY line. So above HP. So now you mark this point as locus of Q. Once you have the end projector and also the distance between the end projectors in the front view, so you got this point and you mark that point as Q dash. Then join P dash Q dash with a dotted line. So where exactly you have got the point now? Exactly the point in space is this line which is P and Q. Now once you get this, now he says the line is inclined at 30 degrees to VP. So where you can see the distance of line inclined at 30 degrees to VP, which will be in HP. So now you draw a line from here which is 30 degrees to VP. We don't know the distance. So you simply draw a line. So when you look from the top view, that point, that image will go to fall here, which is 30 degrees to VP. So continuously it will be moving. So what I want to find out, I want to find out the locus of Q in the top view. So how to do that now? So first initially we will go to how to write the sketch now. So first we are going to draw the XY line and you mark VP and HP here as is shown. Then you know the distance above HP is seen in vertical plane which is 25 mm here, and you know the distance in front of VP, that is this distance, is seen in the horizontal plane here which is 20 mm. So when you rotate this HP down, that HP will go below XY line, so that is the reason why we have written here. So from XY line you measure 25 mm and draw a horizontal line, and similarly from XY line you measure 20 mm and draw a horizontal line. Take any point on this horizontal line and draw a vertical projector such that it will going to cut the horizontal line in the top view also. Then you mark this point as P dash and capital P here, and you mark this point as small p and capital P here. So then you know, when you look from the front view, I can see the distance above HP, that is this distance what you are talking about. So that image will going to fall on the vertical plane. So from XY line you measure 50 mm and draw a horizontal dash dot line, and you mark this as the locus of Q in the top front view. As this end projector will going to cut the locus of Q in the front view, so you mark this point as Q dash. Then join P dash Q dash with a dark line. So we know that distance between the end projectors in the horizontal plane also we are going to have 60 mm. So from Q dash you draw a vertical projector to the top view and extend. Then, and he has given the line is inclined at 30 degrees to VP, which is the line which is inclined at 30 degrees to VP. It is the true inclination line. So from P you measure an angle of 30 degree and draw an inclined line of any length. We don't know where exactly it will going to cut. So to get this top view true length, I should make the front view line parallel to XY. So that we need to do that. So then only you will going to get the true length in the top view. Once you get the true length in the top view, you are going to get the locus line. So this is how you will be able to get this. Now to do that, so what I can do is, I want to get this is the true inclination with respect to VP. So once you know this is the true length, true inclination with respect to VP, but we don't know the true length. But what I know is the front view, if the front view line is parallel to XY, correspondingly in the top view you will going to get the true length. So with P as center, taking the radius of this PQ, draw a horizontal, rotate this in the Q is now, what is the position of the point Q now? The position of the point Q is 50 mm above HP. But what I want, this Q should come such that it will be parallel to HP. So how can I do that? So P is above HP by 25, this Q1 should also above HP by 25. So with P as center, taking the radius of PQ, you rotate this line till this Q will going to become above HP by 25 mm. Then only the line will going to become parallel to HP. As we see the parallel to HP, so you are getting the true length in HP here. So how to do that? So when you are rotating its space, what happens? When you look from the front view, that image will going to fall on the vertical plane. That means where is the front view? Front view is in VP. So you rotate this image such that both P dash and Q1 dash are above HP by 25 mm. So once you do that, so you are going to get PQ1 line is parallel to VP. So this is the actual, parallel to HP. So this is the actual inclination what you will going to get, because this angle is at 30 and then you get the true length where it will go to cuts. So to do that, now I will go to this with P dash as center. By using the compass, make this line P dash Q dash, draw a arc such that both P dash and Q1 dash will be above HP by 25 mm. Now the line becomes parallel to XY in the front view. Correspondingly in the top view, I should get the true length. He has not given the true length, but he has given the true inclination with respect to VP. So when you draw this line, where it cuts, that point will going to be the locus of Q in the top view. That we are going to see in the next slide. So now, as we rotate this, and when you look from the top view, that has been projected onto the horizontal plane. Now you know that this angle is at 30, so both these two lines will going to intersect at this point. You mark this point as Q1. Since this line is parallel to HP, so you are getting the true length. So you mark this as Q, and also you will going to get the locus of Q. Now, how to do that? How you will going to get? Because the front view line is parallel to XY, which is the front view line, which is the front view. Front view is P dash Q dash with P dash as center, taking the radius of P dash Q dash. You have rotated now. That is what we are showing here. As we rotate it in space, correspondingly the image is also being rotated. So your the front view point of Q dash is being rotated with P dash as center, taking the radius of P dash Q dash. You draw an arc such that both P dash and Q1 dash will be above HP by 25 mm. Once you get this, then you draw a projector here. What happens? Then you draw a line inclined at 30 degrees both these 2 points will going to intersect at this point. So this is a actual true length line in the top view. Then you project to the top view so that you will going to get the locus of Q here, and you mark this point as capital Q. This is Q1 and this is the locus of Q, and this is P and capital P. This is because line is parallel to HP. Therefore, you are getting the true length in HP. So how to do that now? By using the sketch. So we have already shown till here. Then draw a vertical projector from Q1 dash to the top view, and from here where you have taken with P as center, taking the protractor, you measure an angle of 30 degrees with respect to the horizontal, and when you draw this, both this line, that is the true inclination line, and also the end projector drawn from the Q1 dash, both two will going to intersect at this point. You mark this point as Q1 and you mark this as capital Q in bracket, and this is the locus of Q. Because the front view line is parallel to XY, therefore in the top view you will going to get the true length. But the inclination is given in the true length, true inclination is given with respect to the top view, but not the true length. So we need to find the true length. Now what we have done, we have found out the true length. We have to measure this length of PQ1 so that you will go to get the true length there. So now once you do that, now what I want the front view now. That is the front view true length. How to get that? So we need to take the top view. How to take the top view? With P as center, taking the radius of PQ which is in space, rotate this in counterclockwise direction. That means both P and Q should be in front of VP by 20 mm. So that is what we are doing. With P as center, taking the radius of PQ, you rotate this point Q such that both P and Q2 are in front of VP by 20 mm. So while doing so, what happens? What I am doing is, with PQ as center, you are rotating and make it parallel to XY line in the top view, so that you will going to get the projector. This has been projected till here. Then once you look from the front view, that line has been projected till to Q2 dash. So that will going to be the locus of Q in the front view. You mark this as P dash, Q2 dash, and this will going to be capital Q, and this will going to be capital Q P, and this will going to be the locus of Q. So this is how you will be able to get the answer. So how do I do that? So here you have got Q dash, but we have not got Q now. Where you are going to get Q? Because the distance between the end projector distance is given, which is 60. I have not shown here, so it is 60 here. So it is both in the front view as well as in the top view, you are going to remain the same. As we got this 30 degree, so you got the locus of Q in the top view. So once you get this, so you know the distance between the end projector in the top view also you will have 60. So from P you measure 60 mm and draw a vertical projector such that it will go to cut the locus of Q in the top view. You mark this point as small q, then join P to Q with a dark line. So now we have now what I need to do, I need to find the true length in the front view. To find the true length in the front view, with P as center, PQ as the radius, you have to rotate so that both P and Q2 are in front of VP by 20 mm. So here with P as center, taking the radius of PQ, you rotate such that both P and Q2 are in front of VP by the same distance, which is P, which is got 20, and here also from XY line to Q2 we are going to get 20 mm in front of VP. Now the line is parallel to XY in the top view. Then you project this point directly onto the locus of Q in the front view. So join and mark that point as Q2 dash, and since this is capital P and this is capital Q. Why? Because the top view line is parallel to XY line in the top view, therefore its corresponding front view. In the top view, what is that line? Is PQ2. Similarly, it is P dash, Q2 dash is parallel to, so it will going to be the true length in the front view. So you got this line. So you measure the angle theta here, and then you find out the true length of this and find the apparent length, and this also the apparent length here. So how to get that? So P dash Q dash will be 65, PQ is equal to 70.77, and theta is equal to 19.56 and 46, and true length will be 75.05 mm when we are measuring it in by using CAD software. But since we are doing it in manual, P dash 2 dash will be 65, PQ will be equal to 71 mm, theta will be equal to 20 degrees, and true length will going to be 75 mm. So this is how you will be able to analyze and draw the solution by using the sketchbook. Finally, we come to the point where how do I know that my problem is right? This is the most important thing in our drawing. How to read that? So we know here, this is the front view. Why? Because in the top view also it is inclined. Okay? This is the true length in the front view because the top view line is parallel to XY. You know that this is the true length in HP. So that means it is true length in the top view. Its corresponding front view, which is that is this line P dash 2 dash, that is P dash 2 dash is parallel to XY. Therefore, you are getting the true length in HP. So that is the top view, and it will be in true length. So this is how you will be able to analyze the problem in 3 dimension, but also solve it by using the manual sketch. Thank you.